Example 8 has us looking at the function absolute value of x. Now we're going to start off the same way. We're going to do an xy table. And we're going to try to take the same approach as the last example where we pick some negatives, 0, as well as some positives. And so as long as they're working well for us, let's stick with -3, -2, -1, 0, 1, 2, and 3. And when we take the absolute value, remember that the definition of absolute value is your distance from 0 on the number line, or the simple way is just make the number positive. Doesn't mean change the sign, it means make the number positive. So if we're talking about 0, 1, 2, or 3, that means don't do anything to it. Just keep it the same. Whereas with -1, -2, and -3, they become +1, +2, and +3. So if we if we plot these guys, those first four that I said, 0, 0, 1, 1, 2, 2, and 3, 3, look to be a nice straight line. Then -1, 1, -2, 2, and -3, 3 are also a straight line. So if you connect the dots here, this will look like a V with a nice point to it. And this is expected if we think about what it means to be an absolute value, because the absolute value says if the x value you're looking at is greater than or equal to 0, then really the y value is just the same thing as the x value was. Because we're not going to change it. We're not going to do anything. Absolute value says make it positive. It's already positive. But if my x value is negative, if it's less than 0, then we are going to change the sign. So the y value is just the opposite of the x. So if we look at what's going on here, this makes sense that on the right side of the graph, we have a slope 1 line, and on the left side of the graph, we have a slope -1 line. So an absolute value graph is going to look kind of like a V.